Let's take a few moments and talk about some more involved absolute value equations. The first thing I want to remember is that absolute value refers to distance away from zero in a number line, and that there will always be, when we're talking about absolute value equations, there will always be two solutions. So as I'm rumbling through this, I want to remember that I'm looking for two answers at the end. The first thing I want to do is deal with all the things that are outside the absolute value sign and get those to one side of my equation. So the very first thing I'm going to do is I'm going to subtract 3 from both sides of this equation. And I get a result of absolute value of x subtract 6 is equal to 6. Now remember that I'm dealing with distance, and this distance in here, there are two values that would make this true. And I would look at a positive distance and a negative distance. So this quantity in here can either be a positive value and end in a result of 6, or it could be a negative value, and when I take the absolute value of the negative value, I would also get positive 6. So I want to think about two scenarios. The first scenario is, okay, let's assume that this is positive, and I could have the equation x subtract 6 is equal to 6. The second scenario I want to consider is, let's consider what the opposite of this might be. If I'm assuming this is positive, then I want to look at the opposite of what that is. And I would denote the opposite by taking the quantity, put it in parentheses, and saying I want to look at the opposite of that. And I also know that that wants to be 6. Well, this one appears fairly easy to solve. I add 6 to both sides. And I get one of my solutions is that x equals 12. Down here, when I'm considering the opposite case, it's a little bit more involved. I'm going to start by distributing the negative sign. I get negative x plus 6 equals 6. I'm going to subtract 6 from both sides. And I get the opposite of x is equal to 0. And I'm going to divide by negative 1. And I get x is equal to 0. Now I'm going to go up and verify that both of these are solutions to my original equation. If I plug in 12, 12 subtract 6 is 6. The absolute value of 6 is 6. The other option I had down here was x equals 0. 0 subtract 6 is negative 6. And the absolute value of negative 6 is 6. Both of these things check out. So let's look at one more example, just to make sure that we have some time with this. So let's look at example 2. Let's make this a little bit more involved. Let's go the absolute value of 2x minus 3 plus 1 equals 11. So just like up above, the first thing I want to do is take care of all the things outside the absolute value symbol. So I want to subtract 1 from both sides so that I can isolate the absolute value. And I get the absolute value of 2x minus 3 is equal to 10. Now I want to consider two options. I want to take this value and set it equal to 10. And I want to look at the opposite of this expression. If I look at the opposite, either the original expression or its opposite are going to be negative. And so I get the positive value and I get the negative values. Now I can solve these independently. I'm going to add 3. 2x equals 13. Divide both sides by 2. And I get x equals 6.5. I'm going to leave it as a decimal. If I come over here to the other side, I'm going to distribute my negative symbol. And I get negative 2x plus 3 equals 10. I'm going to subtract 3. Negative 2x equals 7. Divide by negative 2. And x equals negative 3.5. Now if I've done my math correctly, both of these should work up here. So when I plug in 6.5, 2 times 6.5 is 13, subtract 3 is 10, and the absolute value of 10 is 10. If I plug in negative 3.5, 2 times negative 3.5 is negative 7, subtract 3 is negative 10, and the absolute value of negative 10 is also 10. Both of my answers check out.